All right, so we're going to start with some terminology and some broad concepts first, and then we're going to turn it into. Then we'll do some live coding together with a more specific example. We're going to start with the concept of inheritance. That's the entire chapter. We use the word inheritance to describe when we're defining a new, more specific class based on an existing class. So there's already an existing class. We just want a specialized version of that class with potentially some changed or additional behaviors. We use the word inheritance. This is part of the extended analogy because we want you to make the connections with like genetics and stuff, because that's going to help you understand how inheritance works from a computer science perspective. This new class that we're defining contains or inherits all of the attributes and all of the behaviors of the existing class. And when I say attributes in Java, I mean instance variables. And when I say behaviors in Java, I mean methods. Okay. So it inherits all those attributes and behaviors of the existing class, and it is free to define additional attributes and additional behaviors, and even redefine existing behaviors. Okay. We like inheritance, and we find it very useful because it promotes software reuse. And we'll talk more about what I mean by software reuse later. There is a lot of new terms here in this unit, and so I've tried to put them all in italics, just to like point out to you, like, hey, this is a new word, and to point out to me, I better pause and explain what it means. We say the existing class from which the new class is derived, we use the word derived there, is called the superclass. Okay, I will try really hard to always use the term superclass, and we'll see why later today why I prefer superclass. It's because the word super in it. But there are other terms you're going to read about and hear about too. Sometimes that superclass is called the parent class. That's back to the whole inheritance analogy. Sometimes it's called the base class, although there's a somewhat different connotation there that we're not going to worry about right now. The new class we're making is called the subclass, and I'll try to be consistent and use the term subclass. You will also see it referred to as the child class, again, based on the inheritance analogy. This is our first glimpse at what we call an is-a relationship. Okay, and we'll use these words is-a and has-a a lot to help us understand concepts throughout this unit. But inheritance is a relationship. The subclass is a more specific version of the superclass, and we'll see an example of that in just a moment. This entire year, we've been focused on has-a relationships, which is like aggregation. Let me give you some more concrete examples of has-a relationships. A picture has a collection of pixels. That's a has-a relationship. We wouldn't say a pixel is a picture, right? A pixel isn't a picture, but a picture has a collection of pixels. A pixel has a color. We wouldn't say a color is a pixel, but rather a pixel has a color. Okay, so distinguishing between these two types of relationships is really important. It's something that obviously we haven't struggled with so far because we only had one choice. Everything was a has-a. But now that we have this idea of inheritance, we need to be careful that we use it appropriately. We will be using more and more class diagrams. So here's a class diagram that we're going to be live coding over the next couple of days. It's got three classes in it. Each class is a rectangle. And there's a symbol here, which is like that triangle on the end of the like line. We saw that when we looked at the class diagram when we were doing the collage lab. And we saw that symbol that was used between like simple picture and picture. And I told you not to worry about it yet because we're going to focus on it now. What this means is the triangle points to the superclass. So question is our superclass, and fill-in question and choice questions are the subclasses. So fill-in question and choice question inherit all of the attributes, instance variables, and all of the behaviors, methods, of the question class, but then have additional methods or change the behavior of some of those methods in their subclasses. So we'll be seeing a lot more of these diagrams in this unit just to help us keep track of the relationship among the different classes. All right, so back to a really important question. Who cares? Why do we care about inheritance? We care about inheritance because it promotes software reuse. Why do we care about software reuse? Because we're fundamentally lazy people. That's only partially true, but it is partially true, right? But more seriously, like we don't want to rewrite code. If we write a chunk of code and we write another chunk of code that's really similar to that chunk of code, it's a waste of time, it's a waste of resources, and there's a good chance that we're going to introduce additional bugs, which we're then going to have to track down and fix, and that's also not a good use of resources. So we want to be able to leverage the code that we've already written, and only write new code for like just changes in behavior and new behaviors, and not stuff that's basically the same as before. That's what inheritance gets us. Um, and that's a key part of it. And another key part of this, and this is more the how it does it, not so much the why. How it achieves this, it's done in a couple of ways. And the first way we're going to focus on is the substitution principle. I should have put that in italics. I'll try to fix that here in a second. Um, the substitution principle says, hey, you know what? If you have a variable who's of a superclass type, like question, you can pass a reference to a subclass, and that's okay. So if there is a method that takes a parameter of type question, you can pass a choice question to it, and that's fine. You can pass a fill-in question to it, and that's fine too. And that's, as we're going to see, is like really powerful, and this is where we get our reuse from. All right. When we learn something new, understandably, we're really excited and we want to use it everywhere. Be careful with inheritance. When we're first learning inheritance, students tend to get carried away and they want to make everything inherit from everything. It's not always the right solution. We use inheritance when we have collections of objects that have fundamentally different behaviors. Um, we do not use inheritance when we have objects that simply have different values. Okay. So we have subclasses for choice question, which is like a multiple choice question, and fill in question, which is like a fill in the blank question, because those are fundamentally two different types of questions and they have different behaviors. We don't create subclasses because we have question one on the exam and a different subclass for question two. We don't need that because they just have different values, right? We didn't know anything about subclasses until today, and we were just fine creating multiple turtles that had different pen colors and different positions, and different pen widths, and we didn't ever think twice about doing that, right? So don't forget that. That's how we usually solve problems. Inheritance is something to be used like selectively. So, all right. So here's what we're going to do with live coding here in just a moment. We're going to implement a subclass. And I'm going to show you how a subclass declares that it extends the superclass. I like this word extends because you're thinking like extending the behavior of, and the Java keyword we use is literally extends. We have the option to declare new instance variables, but we will not redeclare the ones we inherit. We don't need to. We just get them automatically. They're still private, so we still need to use mutator and accessor methods. We can't reference them directly, but we won't redeclare them. We might override some inherited methods to change their behavior, and we're going to look at that in a second. And we might define brand new methods too for new behaviors. That's totally okay. So here's like another new term, which is called overriding. When we override a method, what that means is that the subclass has a method with the same name, same number of parameters, and same type of parameters. We call that the method signature. So again, the method signature is comprised of the method name and the number and type of parameters. If the subclass has the same method signature as a method in the superclass, we say it overrides that method, meaning we're going to replace the behavior of the superclass with that of the subclass. That's how the subclass can specialize its behavior. That's what makes it unique. And then we're going to see how we can make those two related. So last thing I want to clarify is this difference between overriding and overloading. So we just saw a definition of overriding for the first time. That's where we're replacing the behavior. Overloading is something that we've done before. Unfortunately, both words start with over, and so they're easily confused. When a subclass has a method with the same signature, we're overriding that method. We're replacing the behavior. When there are multiple methods in a class, whether it's subclasses, superclasses, anything, and they have the same name, but they have a different number or type of parameters, then we're overloading. We have multiple methods that exist all at the same time, and which one gets called depends on the parameters we pass. A good example of that is the picture constructor that we've been using. You can pass a string, which is the name of the image file to load, or you can pass two ints, which is the height and the width, right? So we'd say that the picture constructor is overloaded. We have two different ways of calling the same thing. All right.